When you're on the job site, your rigging is only as strong as your weakest link. Properly anchoring and attaching the aux block is the key to safe rigging. Okay, here we have the aux attached to a load cell, so we can measure the amount of force that's exerted on the anchor point when we support a load. Okay, this anchor point we're going to call hook strain. Right here is our load, which weighs 50 pounds. And this is our haul line, which I'll use to lift the load. So if I'm lifting 50 pounds, how much force in pounds is applied to our hook strain? Well, if I pull down on a haul line, it takes 50 pounds of force to lift a 50-pound weight. So to calculate the hook strain, it's really easy. Just add these two numbers together. That gives us 100 pounds. Knowing our hook strain is very important because this is what our anchorage must be capable of supporting. Okay, I'm going to switch out our load and I'm going to change this out to our 4-part configuration. We know our load is 250 pounds. Now that's the minimum amount of weight that's going to be applied to our hook strain. Now what we need to figure out next is how much force has to be exerted on our haul line in order to lift our load. Now there's two easy ways to calculate this. You can either divide the load by the number of the pulleys or by the number of parted ropes. In this configuration, we have 4 pulleys, 1, 2, 3, 4, and we have 4 parted ropes, 1, 2, 3, 4. So we take 4, divide it into 250 pounds. That's going to be approximately 62 pounds. That is our haul line tension. So when I pull down on a haul line, it's going to take approximately 62 pounds of force to lift 250-pound weight. This again tells us that our haul line plus our load equals our hook strain. And in this case, our hook strain, 312. Okay, next let's change this over to a 6-part configuration. In a 6-part, you're going to see a change in our hook strain and our haul line tension. So we know our load weighs 250 pounds. So this is easy. Again, we divide our load, 250, by the number of pulleys or parted lines, which in this case, we have 6 pulleys, 6 parted lines. So 250 divided by 6 equals approximately 42 pounds. Okay, when I pull down on the haul line, it should take 42 pounds of force to lift a 250-pound load. You know, the other thing that changed is our hook strain. Because remember, we take our haul line tension, which is 42 pounds, plus our load, 250, equals our hook strain, 292 pounds. Okay, let's remove the parted blocks and move on to sling configurations. The aux can be ordered pre-installed with a Buckingham adjustable sling like this. For the most part, there's 4 different sling configurations. The first one I'm going to talk about is a straight. The straight has a working load limit of 3,200 pounds. Next, this one up here, this is a basket. The basket configuration is good for 6,400 pounds. The double basket, this is also good for 6,400 pounds. And finally down here at the bottom, this is a choke. And the choke has a working load limit of 2,560 pounds. Now when rigging with a carabiner, make sure to never cross-gate or tri-load the carabiner. Here's what cross-gating is. Cross-gating is when the load attachment has been placed on the spine or up near the gate, okay? We always want to avoid that. We want to make sure our load is always on the major axis of the carabiner, from here to here. This is the major axis. Tri-loading is when you have a load at both ends of the carabiner and another load on the spine or the gate, like this. So if you're going to use a separate sling, always use 2 carabiners. Never use unauthorized slings or components with the aux. And remember, when using carabiners, always make sure that the gate is away from the structure. Whatever attachment method you choose, make sure that all of your components have at least a working load limit of 2,500 pounds. For more information or questions about rigging with the aux block, refer to Buckingham's instructions and warnings document, or contact them directly.